Yeah, you may type it in the chat box. Awesome. So warm welcome to all of you. Great to see a lot of you turning up for today's session, which indeed is quite an interesting topic right now in the business or in the industry right now. This is a topic that is being getting a lot of traction, and at the same time, it is a topic that a lot of people would really want to dig deeper and want to understand better as to how does it really work, how does it really matter to us, how does it really work, and how does it really affect us in making our decisions more smarter. So welcome to our today's session where we learn how to use machine learning by using one of the most popular packages called as Scikit-learn. And before I go through this session, before I explain all of you what is Scikit-learn, what is machine learning, I would really appreciate if all of you can do a small favor for me. If you can keep your WhatsApps and Facebooks a little away. So technically your mobile phones, if you can just keep it away, except for the folks who are seeing this session on the mobile phone. And the second thing that I would really want from all of you is if you can give me a little information around your name, years of experience, your technology or role, company, and location. So these are the 1, 2, 3, 4, 5. Okay, so these 5 things, if you can quickly put it forward. So we have Hari, 3 years Java. We have Karan. We have Sajesh, 12 years Python. Excellent. So we have Arjun, 10 years testing. Venkat is architect. Narayan is 22 years Chennai BPM product manager. Welcome, Narayan. Nischa is 13 years Hyderabad, and Nischa, you missed out the company. Digant is Oracle developer. Tarun is 3.5 SAP Chennai. Sahil is 8 years, no IT background, Delhi. Excellent. Good to see that somebody from an absolute non-IT background also trying to comprehend what is the space all about. Chetna is 1 year Java developer. Value momentum. Then we have Daksh. Okay, Rahul, Kishore, Raj, automation, Delhi. Rakesh is 3 years engineering and Siemens. Sudeep is Kolkata, 13.8 years. Kinjal, 4+, Mumbai. Pooja, 3+, Python, working in Python, excellent, Siemens. Shrikant is 14 years, Capgemini. Ram Krishna is 6 years, mainframe. Shubham is 5+5, JPMC, Bangalore. Python developer, excellent. So we have quite a few Python developers, and I see a lot of us in today's session are actually people who have a little coding background. But good to see a lot of people not having coding background, and we have a special guest today, friends. I think he's probably the youngest folk out here. So Akash is from class 12. So welcome, Akash. I'm very glad that you have decided that at this age you want to venture out and you want to experiment. Really glad to see that you are trying your best to kind of get into this field, because by the time you would have completed your education, you would have become a lot more matured in this field. So warm welcome to you, Akash. He's our youngest participant probably. He's still studying in class 12. Great to have you. We have really experienced folks also, 17+ years, 22+ years. I think by far, I think 22 is what struck me as the most senior most. I may have missed, but I'm seeing mostly around 12 to 15 years of experience. And a lot of them are from IT, non-IT, and a lot of MBAs in the session today. Excellent. Okay. Okay, yeah. Kudos to Akash, absolutely. Awesome. So Akash, we are very glad that a person of your age has actually ventured into this field. You're trying to make your own grasp in this field. So you see, our purpose for today is not to become an expert overnight, an expert in 1 hour session, but rather our focus today is to see how does the world of machine learning really look. On the outside, everybody talks about machine learning and everybody calls it like a really complex stuff. Is it at all that difficult? Is it at all that complex? And even if it is not complex, what makes it not complex? Okay, so these are the basic ideas that I would like to convey. By the end of the session, I think all of you should have this idea that yes, what seems from the outside is not true. When you get your hands dirty, things fall into place. Okay, so without any further delay, my name is Suchit Majumdar. I'll be your host for today. I will be trying to explain you the idea of machine learning. I'll be trying to explain the idea of Scikit-learn, which is a very popular Python package to do machine learning. Obviously, since it's an open session, we can't expect people to have all the possible prerequisites of knowing how to code in Python, of understanding what machine learning algorithms mean, of understanding what machine learning technically means, of understanding what gets into machine learning, how do you kind of execute it end to end. So you don't have to have all of these things for today. Watch out what we are discussing. With an open mind, if you see what machine learning is all about, I'm pretty sure all of you will realize that it isn't that difficult. Okay, so let's overlook all the prerequisites of the session, which ideally I know a lot of you may not have, a lot of you may have, a lot of you may not have, but I'll try to make it as generic as possible. The coding part, what I would say is look at it from an open mind perspective. You don't have to understand every line of code that I'm going to show you, but at least try to understand what is happening in that part of the code, and you'll see that machine learning is technically not that difficult. Okay, so that is my whole purpose of today's session, to prove you that machine learning is not that difficult. Okay, agenda, I'll keep it straightforward and simple. What is machine learning? What is Scikit-learn? What is why Scikit-learn is like so popular right now? Few of the algorithms that you can do with Scikit-learn, so there are plenty of such algorithms. Case study, just to show you how really we do machine learning using Scikit-learn, I'll actually walk you through a small case study on predicting house prices. So this is what we're going to do in today's session. I'll keep it as entertaining and as exciting and as informative as possible, but I would need all of yours 120% attention. So can I have a quick yes if all of you are absolutely focused and we are all geared up to start the session? Excellent. Thank you. This is what I wanted. The yeses are flowing in like crazy. Thanks a lot. Okay, let's get started. First things first, what is machine learning? A lot of you may already know what is machine learning, but for the ones who don't know, let me explain you what is machine learning. So suppose I know that there are these fruits which are red in color, round in shape, and maybe 250 grams, around 250 grams, and they taste sweet. They taste sweet. Okay, they have maybe they have a leaf at the top. Okay, there's a top leaf which comes out of a small stem. Okay, now these properties define what? They define an apple. They define an apple. We as humans understand that this is an apple because we have seen these properties, and somebody has taught us that when these properties match, it is called as an apple. So recall back when you were a kid, when you were a toddler. Our parents used to show us images, and we used to get the feel as what are the attributes of those images, and based on that we used to learn that this is called as an apple. So I had some inputs which were mapped to an output. Okay, inputs of the apple are basically the features of the apple, and the output was, I was told that it's called as an apple. Would you all agree to this point? As toddlers, we used to see pictures and we used to try understanding, okay, these are the features, and based on these features, I knew that it's called as an apple because somebody told me it's an apple. Would you all agree to this point? So you can give me a quick yes so that we can go forward. So inputs are the features of the apple, and the output was that it belongs to the class apple. It's a fruit called as apple. So as toddler, this is what I was taught. Machines also learn the same way. The only thing is, in machines, you don't need a parent to continuously tell that this is an apple, this is an apple, this is an apple, this is an apple. As a kid, you had that guidance from your parent to tell you this is an apple. So for the machines, the good part is what we do now is we have plenty of data where we have information about, say, 1 million apples. So we have studied millions of apples, and we have collected the shape, size, weight, the color, the sweetness. Okay, what all attributes are there, and we define that this fruit is that of an apple. Another fruit which is long, yellow, it's kind of, there's a thick skin, and then there's a small black kind of stem at the top. It's called as a banana. So suppose I have such millions of data points. I have millions of data points where I have the inputs of different fruits given against their names. So suppose there were a set of 500 million such apples. Okay, not 500 million, maybe a few thousands of apples, few thousands of bananas, few thousands of grapes. If I had such a database, if I had such a data of fruits and their corresponding features, all I had to do was give it to the machine and let the machine learn the features. The machine would learn, okay, these are the features that defines an apple. How does it do? It uses a concept called as algorithm. Okay, there are specific algorithms that usually we feed to the machines, which along with the data helps the machine learn. Okay, it's as simple as that. You need to tell the machine that, see, this is the data. These are the features for those fruits. You try to understand what are the common features for apples, what are the common features for bananas, what are the common features for grapes. Okay, and based on those features, once you have a fair idea, next time when I give you certain features like it's a long fruit, okay, the skin is a little thick, inside it is white in color, usually it is sweet, okay, and it's a little curved. What kind of fruit is it? The machine is supposed to answer this. But how does the machine answer? Based on its historical knowledge of the fruits. It has gone through all of these fruits details and figured out that usually the yellowish color fruits, which are a little curved, the inside, the flesh is white in color, the skin is yellow in color, and so on parameters, so on and so forth are the parameters. These parameters define a fruit called as banana. Okay, for the machine, what is a banana? That really doesn't matter, but it understands that these features are called as banana. So next time when I give similar features, or in future when I don't know what fruit it is, but I will give the features of the fruit, that it's a yellow color fruit, it's longish in nature, a little curved, inside flesh is white, the outside skin is a little thick. The machine can go through the historical patterns, and based on its analysis of the historical patterns, it will deduce the output and say that, yes, this is called as a banana. This is all what machines do. You feed them a lot of historical data. Based on the patterns that it finds, it answers your future queries. This is called as prediction. Okay. Now the question is, does the machine, if the machine is making prediction, does it need to be 100% accurate? How many of you feel the machine should be 100% accurate? How many of you feel so, that the machine needs to be 100% accurate? So I see I mean, very few people really answering the same thing, that no, we would want it to be 100% accurate. No, nobody is interested in being 100% accurate. But you would try to be as close as possible to the real world. You don't have to be 100% accurate. A yellow long fruit, this in itself can give me a fair idea that it's banana. So do I need to know every parameter in and out? Maybe not. Okay, there are few parameters that really defines a banana, and if you're anywhere close to it, I can call it a banana, but I may be mistaken. But that's totally okay, as long as most of my answers are correct. In real world, answers will not always be static, because humans are very dynamic in nature. The data will always keep changing. Okay, so we'll not get into all those technicalities around machine learning and how good or bad it is. But at a very ground root level, if you'll focus on this idea that there's a pattern, that my potatoes on odd days are odd, and on even days it's even. Okay, so you see here, on odd days it is odd, on even days it is even. If so much of information is fed to the machine can learn patterns. It'll learn that, okay, odd days the value is even, and on the even days the value is odd. Okay, so 16 is on odd days and 17 is on even days. Now this is a pattern that the machine can dig from millions of data points. As humans, are we very capable of learning all the possible data points? No, we really can't. But machines are very good at it. Okay, so what happens is, we feed a lot of data to the machines. We ask the machine that you train yourself, okay, understand yourself, understand the data using algorithms. Okay, and how do you train yourself? You use algorithms to understand the patterns. Based on that, once you understand the pattern, the next time when I feed you in an input, you should be able to tell the output. So in this case, as you see, the machine can predict the output as it's an apple based on the tons of inputs that we have given. And not always do you have to be 100% accurate. Anywhere close is okay. Here you're seeing a green apple, but our input was all about red apple. But it's just that most of the ideas really match that to an apple. So the machine need not always be 100% correct, but it will try to be as close as possible to the real world. Now, to make this idea a little more easier for all of you, let me make the idea a little more easier for all of you. Okay, look at this data. If you look at this data is about the price of a flat in lakhs. Okay, so Indian rupees lakhs based on the square feet area of the flat. Now, when I plot this data, what can you suggest me? When I plot this data, what can you suggest me about the relationship between the area of a flat and the price of a flat? What kind of relation exists? Raga says it's a linear trend. Yes. It's linear proportional. Absolutely. Directly proportional would be the more precise answer. Okay, it's a directly proportional relationship. Any rocket science here? Anything difficult here? To understand this pattern, do you think there's anything difficult? No. Okay. It's a very straightforward relationship. As my square feet increases, as my size of the house increases, what also increases? The price also keeps increasing. So it's a directly proportional relationship. Now, in real world, obviously it won't be so straightforward. You might have the prices a little here and there. Okay, the prices would be a little here and there. But still, I would request all of you to look at this diagram and tell me one thing. Still, is there a possibility that I can predict prices based on this kind of data? Is there any possibility that I can still predict price on this kind of data? Somewhat yes. Somewhat yes. I won't say I'll be 100% accurate, but at least I'll be scientifically correct to some extent, that the price should be somewhere close to this line. Okay, this was an exception. This might be a house which had Italian marbles, so that's why it just skyrocketed somewhere. But otherwise, if you see, most of the houses are in this range, and to some extent, I'm still smarter. I'm still smart at predicting that a 1700 square feet would have costed somewhere around 120k pounds. Isn't this more logical in some sense, as opposed to blindly just claiming a 1700 square feet house would have been 50,000 pounds? I could have blindly, like, or you ask a monkey to pick a number, a monkey could have picked up 50,000 pounds. Now the point is, instead of going by whims and fancies, instead of going by random thoughts, instead of going by some random idea, wouldn't it be a tad bit better if I use science to look at this pattern and say, yes, it will be around 17. So 1700 square feet is around 120k thousand pounds. So 120k pounds. Would you all agree that this is at least scientifically smarter than just giving a random guess? Right? What if, okay, what if I added some more information around this? So right now you have the floor area. What if I added the number of bedrooms? What if I added the number of bedrooms? Would that really add some value to your analysis of price? Would that make your analysis of price a little bit better? Suppose I added bedrooms, and obviously one bedroom houses have lesser square feet and lesser price. Two bedrooms have a little more square feet and a little more price. Three bedroom has proportionally more. Okay, so you see, the more information I start adding to this data, as humans, what happens? You start appreciating the data. You start understanding the pattern better in the data. But the question is, friends, what if I give you 10 columns? Okay, what if I give you 10 attributes of a data? Can you find all the patterns within those 10 attributes? Something like upscale society, something like distance from school and hospital, something like how many malls are there around you, something like what is the kind of sanitation in that area, something like. So if I start giving you more and more and more and more and more and more and more information, will you be able to find all the possible patterns between price and the other attributes? As humans, are you receptible to that kind of volume of information? If I ask you to understand this idea for close to 1,000 houses in your society, so in the society that you stay, can you understand the pattern between, say, 15 of such variables, 15 of such attributes? You see, humans are not very good at it. Okay, it's technically impossible for humans to digest that kind of amount of data and find patterns. I might say that, okay, this is a 2 BHK flat. This has the sanitation score is 96, based on the distance between the house and the commercial area. It's like 2 kilometers. Between school and the house is 5 kilometers. The number of tenants that have used this, how old the house is 12 years, number of tenants who have stayed here is 4. The last time the damage, the property was kind of scanned throughout was in the year 2004. Dot, 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 dot. I keep adding more and more information, which leads to a price called as, say, 150K. 150K pound. But the question is, this is just for one house. If I ask you to identify the pattern for your society, which has close to, say, 1,000 such houses, would it be possible for you as a human to look through all the 1,000 rows of data with so many data points and all the prices to give you a fair idea that, yes, the next house which has so and so properties of, say, 3 BHK, it is scored at 98, it has 3 bedrooms or something, dot, 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 and 15 other variables. This kind of house should ideally be priced at around 127K. Would you be able to make this call by looking at so many data points, close to 15,000 variables and 15,000 prices? 1,000 prices? Totally no. As humans, I can't make sense of so much of information, right? You would need Sherlock Holmes' mind. Absolutely. And I would doubt even if Sherlock Holmes would be able to crack this. So the whole point is, as humans, you understand we are limited, but we have brains. We know how to think, and we know how patterns work in real world. So rather than me doing the hard work, why not push it onto the machines? Let the machines crunch so much volume of data. Machines are good at it. They don't mind. You give them 15 columns, 1,000 rows, okay, 15 columns with all the properties of the houses and the prices, the historical prices. I had these houses being sold for 120K, 121K, 135K, 90K, dot, dot, dot. You give 1,000 such values, okay? The computer will happily digest all of these values, look for patterns, and the next time you give another set of 15 values for a house that you want to sell, okay, those values would be, it's a 4 BHK, it has square feet of some 1,800 square feet, dot, 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 whatever other parameters are there. You ask the computer, can you now tell me what should the ideal scientific value be? Remember the previous case. Scientific value is this, okay? A random value is somewhere here, or it could be here, or it could be here, or it could be here. It could be anywhere. That's a random value. But a scientific value is one which is made based on patterns. A machine will find a pattern and give you a scientific value. And that is what machine learning is all about. In today's life, if you have to really trust a broker versus a machine, I would say, please trust machine any day. A broker has some bias. Can you tell me what is the bias of a broker while selling a house? It's his commission. Absolutely. Excellent. The broker is interested in his brokerage or commission. That's why he'll jack up the prices, make as much money as possible. So I would rather go for a machine to do that. Okay, let machine look at historical prices and see what humans are usually paying for this kind of flat. And trust me, for the machine, finding that pattern is no big deal. Okay, so absolutely, when I have so many parameters, the interest rate, economic growth, households, affordability of housing, number of houses being sold, if I have so many variables around the price of a house, as humans, I'm not very capable at scientifically deducing the idea of the price of the house. I would rather bank on machines to learn and solve my problem. And that's where machine learning is so powerful and so beneficial. Makes your life really smart, makes it scientific, and a lot of businesses are benefiting based on the scientific outcome. Now, applying machine learning sounds a little weird, sounds a little complicated, especially for the ones who are not programmers. For you, all the more difficult to understand that, okay, how can you really apply machine learning? I don't know coding as of now. For that, there's a very beautiful answer that the Python community has come up with. The whole idea why Python was developed was because this was a language that anybody to everybody would have been using. And today it is a fact. Everybody uses Python. You come from any background, really doesn't matter. There are people who come from biology, they use Python. There are people who are in creative arts, they use Python. There are people working in construction, they use Python. Everybody can use Python because this language was written in such a way that anybody could understand and use it. Okay, so the biggest benefit of using Python is it's easy, very easy to learn. The second biggest benefit is it's called as packages. What is packages? I believe a lot of you have used Excel sheet. Okay, can I have a yes if you have used Excel sheet? Great. So I see most of you have used Excel sheet. In Excel sheet, there's something called as VLOOKUP. And I believe a lot of you have used this idea of VLOOKUP. The question is, VLOOKUP has 4 parameters that you need to pass to use VLOOKUP. That's it. You have to pass 4 parameters that you need to pass to use VLOOKUP. How many of you actually have ever thought what is there underlying in VLOOKUP? How is VLOOKUP implemented inside the Microsoft Office in VC++ code? How many of you have really looked into that? I doubt anybody would have done that. Because you're least interested in the implementation of VLOOKUP, but you're rather interested in the usage of VLOOKUP to solve a business problem. So the point is, even if you have looked up, really does it really change your life? Nothing. It adds no value to you immediately. Okay, so the best value that you derive is, as a business person, I use this particular function directly. Excel gives me a shortcut way of using it directly, and I do it to solve my business problem. So I hope all of you realize that solving the business problem takes a precedence over solving the actual code, understanding the actual code. So you need to just understand this bit and use it. Would you all agree with me on this point? Because all of you are using VLOOKUP, and I doubt 100% of you actually have seen this actual code underlying VLOOKUP. You are more interested to solve a business problem than actually looking into the code. That's not our headache. That's the headache of experts. Experts are creating these stuffs. I don't care. My job is to use their knowledge to solve my business problem. All I have to learn is this bit. And this is given in Python by using packages. Packages makes your life so easy that you'll be surprised to know machine learning is hardly 4 lines of code. 4 lines of code, most of it being repeated. How many of you feel that, okay, this is not what I thought about machine learning, that it should be a 4-line code and most of it is repeated? So how many of you had the assumption that machine learning would be tons of lines of code? If you're doing just the machine learning part, hardly 4 to 5 lines of code, and I'll actually show it to you. I'll prove it to you. Okay, so every Thursday, whatever session I take, I make it a point, I show you. I'll not claim, I'll show it to you. So the whole reason why packages are so popular is Python wanted to make the life easy for everybody. Okay, the community wanted to make life easy for everybody. Just like BMW, such a big company who can easily afford to run its own research and development for making the best tires on this planet, does not manufacture tire. This tire that you're seeing is Bridgestone tire. The car is BMW. So BMW never builds its own tires. It rather uses somebody else's expertise. BMW is interested in making beautiful cars. The expertise is in making awesome cars and not making awesome tires. For awesome tires, they can always buy it from Bridgestone. On similar lines, your job is not to build really complex algorithms. You're not going to write algorithms by yourself. Why? There are plenty of smart folks out there who actually understand the nitty-gritties of algorithm and they build it. As a person of business, as a person who's contributing back to the company, my job is not to understand this underlying code, but rather to use my machine learning to solve a business problem. To understand how do I solve a business problem. That is more important. Look back at VLOOKUP and that should answer your own question that do I ever need to break my head about the underlying implementation of VLOOKUP, or should I know how to use VLOOKUP to solve my business problem? And that's where Scikit-learn is so popular. It makes your life as straightforward as using ready-made code to solve your business problem. Your focus is on the business problem and less on the actual implementation of the algorithm. You understand at a high level what these algorithms mean, how does it fit back to your real world, and then use it. That's it. Just like just like you have invested time to understand what are the parameters in VLOOKUP that I need to know to use VLOOKUP to solve my business problem. As simple as that. How many of you feel a little relieved that yes, machine learning isn't that difficult as it seems on the outside? How many of you are mildly relieved? Okay, good to see a lot of you are relieved. So yes, all the yeses, I really appreciate that you are watching this from an open mind perspective. Okay, the whole point is, what I would really recommend is, with the same open-mindedness, please also look at the code. I know a lot of you are non-programmers. Don't worry. The code is, it might seem a little daunting initially, but it's only because you may not have seen Python ever. But the ones who work in Python, they'll call this a cakewalk. Okay, so it's actually that easy. It's going to be that easy that you'll see a lot of these code are actually very repetitive. A lot of these codes are very repetitive in nature. And if you understand how to use it, it's very much like using VLOOKUP on Excel, as simple as that. Now, packages have been built and Python has plenty of such packages that makes our lives really, really easy and straightforward. So why Scikit is so popular? Scikit is one such package which helps make machine learning layman. It makes machine learning totally open for everybody and anybody to everybody to use machine learning. It makes it so layman. The models that are chosen and implemented, okay, they are done by a dedicated team of experts, people who hold PhDs, double PhDs. You really can't beat their knowledge while creating algorithms, but they can't beat you while solving your business problem because you know your business problem. They don't understand every business problem. They know how to write a good algorithm, but using that algorithm is in your hands. So don't break your head to first understand every bit of algorithm. Rather, break your head to use every algorithm to solve your problem. That is more important. All the possible algorithms that fit to solve your problem, use them. Second, covers most of the machine learning tasks. So whatever tasks that usually underlie in the machine learning life cycle, most of these tasks you can automatically use by using Scikit-learn. A lot of these tasks become very simple if you use Scikit-learn. It focuses on the end goal. The end goal is what? Your business problem. So your business needs a solution. The focus of Scikit-learn is on the solution, okay, and not on the actual algorithm implementation. It tries to look at the end goal. What is my end goal? How can I achieve it quickly? Finally, Scikit-learn is good enough to solve most of the data problems. Okay, why do I claim this? Is because very few companies are dealing with data in terabytes right now, or petabytes. Okay, on a daily basis. Very few companies are dealing with this volume of data, terabyte and petabyte on a daily basis. Scikit is sufficient to solve most of the gigabyte issues. Okay, Zeta is like, that even Facebook doesn't have. Okay, so on a daily basis, Facebook may reach some petabytes, but not Zeta. Okay, so the whole point is few gigabytes. I think Scikit-learn is sufficient to solve most of your business problems. And that's why this package is so powerful. Now, as I promised, that machine learning is hardly these 4 or 5 lines of code. So look at it very carefully, my friends, and you'll see me repeating these codes whenever I use a different algorithm. Nothing will change. First things first, select the algo. How do you select the algo? Somebody has done the hard work. Just import that person's hard work. Okay, he's smarter than me at writing algorithms, but I'm smart at solving business problem. So I will use his algorithm to solve my business problem. So in machine learning, first you have to train the machine to find the pattern. How do you do that? This is the only line, dot fit, and then you pass your input data and the output data. So if you remember, the attributes of the house and the price of the house, attributes of the house, price of the house, attributes of the house, price of the house. These are all my historically collected data. Input is X train, output is Y train. To understand if my machine has learned the pattern properly, I will keep few question and answers separate. So if you had, say, 100 such houses. Okay, so or rather let me just explain this idea with a more easier example. As a teacher, I have 100 questions and answers. I have 100 questions and their corresponding 100 answers. So I want to make sure that students understand the subject well. So what I can do is I can extract 80 questions from this along with their answers. And what I can do is I can keep 20 questions and 20 answers separately. These 80 question and answers, I will show it to the student. For every question, what is the answer? For every question, what is the answer? Something like 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 2 is 6. Okay, so what I'll do is I'll make such 80 question and answers and I'll show it to the students. So I'm technically training my students. I'm training my students how to add two numbers. After this, to understand if the students have really understood the topic properly or not, what do I do? If a student has really understood the idea of addition, what do I do next? I have 20 question and answers with me. Do I give a test with both the question and answers to the student, or I take a test by only giving the questions to the student? Yes, friends. I will only give the questions, as simple as that. In the first 80 examples, I showed both the question and the answer for them to find the pattern that, okay, this is called as addition. What it does is it adds the two numbers and gives you the output. But in the test, what I'll do is I have 20 question and answers separately. I'll hide this answer. I will only give the question to the student. So in the test phase, I will give 20 questions to the student, which is the input. Basically, it's the input here to the student. The student is supposed to give you the answers. Okay, the student is supposed to give you the answers. So whatever student has answered, how do you know if the student is good or bad? You will evaluate. You'll see if the student has answered properly or not. So with the already 20 answers that you had hit from the student, you're going to compare with the student's answer. Based on this comparison, you decide a score. Okay, and that's how we rate if a student is good or bad. So suppose out of 20 questions, the student has answered 19. That is pretty good. And finally, if you know that the student is good, you can give him a job, and in your company, he performs excellent while you give him new numbers like 422 plus 444. Okay, since the student was a good learned student, he found the models, using the model, he found the patterns pretty well. And based on his analysis that this guy could make really good answers for all the test questions, I hired him for my company, where he could easily add two numbers and give me the right answers. Okay, this is how even machine learning works. You give the machine a lot of input and output data, historical data. You ask it to find patterns by using dot fit. It's called as the training phase. Once it finds the pattern, you pass new questions or new inputs to this model. You tell the model that these are my new inputs. Why don't you answer what is the answer for these 20 inputs? The machine will answer the 20 answers, okay? And this is the machine's answer. So let's put at A dash. Machine answers A dash. You already had saved these 20 answers before because you knew the answers beforehand. So you wanted to validate, right? You wanted to compare if the student is good or bad. So you'll compare with the 20 answer key that you have. And based on this analysis, if you find that the machine is good, okay, at answering most of the questions, you can go ahead and use it. Alternately, how can a score really help? How does a score help apart from telling if a student is good or bad at answering the questions? Apart from telling a student is good or bad at answering a question, how does a score really help? Between students. So between students, you can say which student is the best. Okay, so between different models, you can tell which model is the best. Okay, if you have used say 5 models, okay, you can say, okay, the 4th model has the highest score, I will choose the 4th model. Okay, so machine learning works in no different way. It works on similar lines. These are the 5 lines of code that you can use to solve your machine learning problems. I'll show it to you in action. I'll actually walk you through the code, and that's how you can really make sense out of it. So it's about a house price prediction. Don't worry if you don't understand every bit of the code right now. I don't expect all of you to really follow every bit of the code because it requires you a little learning outside what we are doing right now. So you have to know a few things beforehand. A lot of you may not know Python in itself. So it really doesn't change anything much, but at least you'll get the idea that yes, in real life, machine learning isn't that difficult. So let me go through all the ideas that I spoke in the class. I'll walk you through all of those ideas once again, but I'll show it to you in a coded form. So first things first, as I told you, I don't have to be an expert in writing every bit of code. I don't know how to read a file in Python in the best possible way. So I have something called as pandas. Pandas is one of those packages which makes my life really easy, really simple. In just one line of code, I can beautifully read a package. If you ask your friends who are actually coders, you ask them that, okay, how many lines of code is usually required to read a file in a fail-safe mechanism? So people who are in Java or C, if you can address this question, how many lines of code do you usually use to read a file without getting too much of issues? Excellent. 10 to 20 lines. Okay. So as Murli says, around 10 to 20 lines. If you are writing without any kind of validation, maybe 5 lines. But yes, you got to write validation to make it a fail-safe mechanism. Neville says 20 lines. Yes, at least. Veena says 10 to 20. Yes, that's how many lines you need to write to read a file. But in Python, do you see, because somebody else is smart enough, I don't have to write the entire code. He's written the code. I'll just use a simple idea of pd.readcsv. The file name is called as houseprices.csv. Let's check what is the houseprices.csv. I'll see the first 5 rows. This is for the first 5 rows. Dot head means the top part of the data. So it has something like crim, which is criminal records, ZN, Indus, CHAS, NOx. These are all the attributes about a house. It's the properties of a house which decide the price of the house. I hope all of you understand this bit, that these are certain inputs, attributes about the house. These are all my historically sold houses. These houses were sold some time back. And based on these inputs, this was the price that people paid for the flats. Okay, so does this make sense? You don't have to understand the inputs, what it is. I'll tell you in a bit. But I hope all of you understand that based on these properties of every house, so each row is basically one house. And based on the input properties, the price was decided for that house. So it was sold for 24,000 pounds, okay, or $24,000. So the whole point here is every house had certain input features based on which I could decide the price of the house. So this is my historical data. Nobody calculated this value. Okay, it is my historical data. These were the properties of the house and the corresponding price at which it was sold. I will use these ideas to find patterns. I'll use all of these records to find patterns about how does these parameters relate to the price of a house. Once I know the pattern, next time you want to sell a house, you give me these 15 parameters for that house and I will tell you what is the price of the house. That is what machine learning is all about. Finding patterns and then solving your real world problem. So let's look at what are the columns. The columns are basically per capita criminal rate, crime rate in that particular town, proportion of residential land zoned for lots over 25,000 square feet, proportion of non-retail business acre per town. CHAS is basically Charles River, dummy variable 1 if track bounds, 0 if otherwise. So you don't really have to understand what does dummy variable and all of these parameters really mean. But as long as you are able to grasp the idea that each of these are one attribute that defines a house. Okay, if it is if the river is around the flat, around the area of that building is, it is 1, otherwise it is 0. Nitric oxide concentration, yes, it is important at times to know what kind of pollution you have in the air, and that also decides the price of a flat. Okay, if it's a very polluted area, would you really want to kind of buy a flat there? Maybe not, and the prices automatically dip. Average number of rooms per dwelling, proportion of owner-occupied buildings, weighted distance of 5 Boston employment centers. So how far are you from different places? Indexes of accessibility to radial highways. So how far are you from the highways? Full value property tax and pupil-teacher ratio. So how is the ratio of education? So schooling in terms of teacher and students. These are all attributes that decide the price of a house. Okay, at the end of the day, these all attributes will actually go ahead and decide the price of the house in thousands. Now the question is, as I told you, for the machine to learn the patterns, what I will do is Suppose I had 100 questions, I will keep 80 for training the machines. Okay, 80 question and answers I will use for training the machines. So I will show both the input and output to the machine, and the machine will find the patterns. And then the rest 20 questions I will show to the machine and ask what is the answer. I will hold on to the answer key, and once the machine has answered, say A dash is the machine's answer for the 20 questions. I will compare these two questions, these 20 questions, which I'll compare with the answer key, and finally understand. This is called as evaluation. I will understand how good the machine is at predicting. Okay. So what is input here and what is output? Input are the parameters of the house, and output is the price of the house. So inputs to outputs is what we are interested in. Okay. Now, what we have to do is, as I told you, I'll split the data into two parts. Okay. One part I will help train the machine. Okay. One part I'll help train the machine. So this is basically the 80% data where these are the inputs. Y train is the 80% output. Okay. Output is nothing but the price. And similarly, for testing, I will hold on to 20 questions, which are the 20 inputs, and 20 answers, which are the actual answers. I'll hide this and compare with what the machine is replying. Okay, so this is how I split my data. So out of the total, say 506 rows of data that I have, 404 inputs, okay, of all the columns and all the outputs, I will save it separately. Okay, Akash, dropping is basically what I'm doing is, these are every column outside apart from drop is basically what? Those are my attributes of the house. They decide the attribute. They are basically the deciding factor of the house. So I'm removing the price, and whatever is left over, that becomes my input. So if I drop price from this data here, what do I see? I see all the input columns. These are all the input columns. Input attributes that decide the price of the house. So price is the output. Okay, that's what we are doing. Okay, don't get into the code, friends. Don't even try to understand the code in every bit of it. Test size 0.2 means you'll have 20 questions and 80 training. Okay, 80% of the data will go for training, 20% will go for testing. Don't understand what is random state right now. Not important right now. These are things that you understand once you get into this field. But what is important is to understand how machine learning really works on the outside. If you see this, it's not going to be very difficult. Once you are in this field, these things will automatically start making sense for you. Okay. So I prepared, as a teacher, what did I do? I prepared my 80 question and answers, and then I kept 20 to test if the machine is good or not. Okay. So I kept 20 separately. Now, here comes the interesting part for which you all have been waiting for so long. How does machine learning really work? Again, you import Scikit-learn's which model you want to use. So which algorithm you want to use. I want to use linear regression. Okay. I want to use linear regression. This is a very tough code, which if I were to write, it would have taken me ages to write. But rather, some expert has written it for me. So I don't really have to break my head. I will use that. I'll use that algorithm to create my model. I'll tell the model that why don't you learn the input and the output relationship, the patterns between the 80% questions or inputs and the 80% answers or outputs. Okay. So all the features of the house that decide the price of the house. So I have historical data. So I tell that please learn the relationship between the input and the output. Just one line. That's it. Model.fit. This is for helping the machine learn the pattern. Okay. Helping the machine learn the pattern. Once the machine learns the pattern, I will ask it to predict my 20 question. So I have 20% questions and answers, which I have kept it separately. I will pass the 20% questions and ask the machine to answer all these questions. The machine will give me some Y test. Okay, it'll give me the answers for this. So basically, say the answer is 20 A dash. So 20% of that data, it will give me A dash. So those 20 questions that it answered as A dash, I will compare with A. So this is the output. This is the actual output that I expected, which is my answer key. This is my answer key. And this is the machine given output. What am I doing? I'm trying to find the error. Okay. and based on that, I will find a score. Okay, you don't have to understand what is the RMSE or R square right now. Just think of it as error and the score. So if you have 100 questions, if the total marks is 100, if you have say 20 as your error, or let's make it as 25. If you have 25 questions which are wrong, okay, so this is your error. In some sense, you can think of it as error. And what is your score? Your score is 75. Okay, so higher the score, R square, better the score, better the candidate, lesser the error, better the candidate. So that is what we are trying to find here to understand how good or bad the model is. So in the first case, the model tried to learn a pattern between those 80 question and answers. After it had learned a pattern, I asked it to give a test to understand how good it did it learn. So on the 20 questions, I gave it a test. It gave me the answers. I tried to find the score of the model, and I figured out that the score is somewhere around 0.73. The closer it is to 100% or 1, the better it is, but not always the same way. In machine learning, there are smaller nitty-gritties around R square being a little high does not always mean it's a good model. But those are things you learn very specifically once you are in machine learning. Right now, just assume that, okay, a better score is always a better model. Now, this error also gives you a reflection of how bad is your model. Okay, if your error is large, it is bad. The prices, if you remember, were around 24 to 25K. Okay, in the data, if you had seen, these prices are around 24 to 25K. So somewhere 21, 24. So these are the prices that the houses have. 4 is roughly, I would say it's a small percent. It's like 20% of the value. So totally okay. Okay, 20% error is totally okay, but obviously it makes a lot of difference if you could actually come and reduce it further. So the whole point is this algorithm learned some patterns. You tested the algorithm to see if the algorithm was good enough at solving a business problem. You got some valuations to understand if the model is good or bad. Now, suppose you accept that, yes, the model is good enough for me to use in business. What do I do next? I directly use it for my final predictions. So in future, if some business person comes and tells me, Suchit, I want to sell my house. These are the properties for criminal rate, for nitric oxide, for is it close to this particular river? Okay, this is the kind of age of the house. So, and the rest of the properties, the taxes and other properties of the house. If this business person gives me all these inputs, I can use this model that I had before to calculate the output. So I can directly use the output, and it says roughly $27. Where's $27,000? Now, friends, this data that I have is very close to this large data. Okay, I just copy pasted the large data. I changed one parameter. Instead of 2.18, I made it 2.22. Okay, so I made it 2.28. So if you see here, it is 2.28. So the price should also be somewhere close. The price shouldn't be too far. The price is roughly $10,000 difference. So it's not really a great output, right? The output is not really great. And this happens when in machine learning, you realize that not every algorithm is going to solve every problem. So once you have that feel that not every algorithm is solving my every problem, what do you do next? You move to the next algorithm. Okay, you move to the next algorithm. But friends, before I move to the next algorithm, can we all have a quick look at how did I implement the first algorithm? I want all of you to focus on this back. Okay, don't even try to understand the code. Understand the steps that should take you to places right now. Okay, you don't have to understand everything right now. Don't push too hard on this. See the patterns, and your machine will learn very fast. You are a human machine, right? So you will also learn very fast. Okay. First, select which algorithm you want to use to solve your business problem. I used some ready-made code that is already available. Second, understand how will you evaluate. So I will also, again, for evaluation also, I will use some ready-made code. I'll not break my head on evaluation. So first things first, you use your algorithm that you want to use to solve your business problem. Using this algorithm, you try to train your machine. You told the machine that, see, I had all the inputs about the houses, and there are the prices for that houses, for those set of houses. These are like my 80 question and answers that the teacher is showing to the students to train them. Okay, once the machine is trained, what do? I give it 20 questions for test. The teacher already has the answer key. The 20 answer key is already with the teacher. The student, which is the machine here, will give you another 20 answers which the machine is predicting. How do I know if the prediction is good or bad? I will compare these 20 actual answers with the machine answers. Based on that, I will score the machine learning algorithm. I'll see how good or bad it has performed. Once I've scored, I know that yes, it is good or bad to some sense. Okay, to some extent, I can say, okay, this is okay. Is this good or bad? I can tell from my business perspective. Okay, finally, once you know that, you are going to, if you're convinced that the model is good enough, what do? You use it for actual prediction in real world. In real world, you'll see a data which is not already seen by the machine. This is a fresh data. A new guy has come to sell his house. He tells, these are the properties of my house. Please tell me what is the price of my house. And then you beautifully give the price of the house by using the predict function. You see, machine has learned the pattern, and based on the pattern, it is able to predict the output. Now the important question is, these were the 5 standard steps of machine learning, and I'd already claimed this before. So let me prove it to you that now I will use 2 or 3 more models. All of them will follow almost 80% of the code will be same. Let's see how. I will use a decision tree. You don't have to understand what is a decision tree, what is a linear regression. These are all different kinds of models to solve business problems. Okay, so one more type of algorithm is decision tree. So once you learn machine learning, these things will always all become very obvious for all of you. It will become very simple for you. So if you remember in the previous case, I imported linear regression. I imported linear regressor, which was in Scikit-learn. Sklearn is basically a short for Scikit-learn. In this case, I will use decision tree. I'll use a different algorithm. So I will use this algorithm. I will again fit the data. Okay, again the same steps, friends. Please watch this very carefully. Again the same steps where I will give the 80% data. So 80 question and answers to help the machine learn the patterns. This is called as the training. Okay, this is training. Then I will give 20 questions which I've hidden, which I actually had taken out from the original data. And I will maintain the 20 answers with myself, which is the answer key. I'll see what the machine answers for these 20 answers. And based on this, I will evaluate. I'll score the machine if it is good or bad. Please remember, this is a different model. Okay. And based on the scoring, finally, if I'm convinced that if this model is good enough, what I do, I predict on future data. Are the steps similar in nature? Are you guys finding a drastic similarity in the code? This is different and this part is different. Rest part, if you see, it is exactly the same. My algorithm has changed and whatever parameters I passed to the algorithm, that has changed. Rest bit of code is a total copy paste. Totally reusable code, absolutely. Let's see if this algorithm is better than the previous algorithm. So friends, please help me out. The previous algorithm, okay, the price for this house was $27,000. As I told you, the actual price is close to $36,000. This was doing okayish. It was okayish. But let's see what did decision tree help me out with. What was the output of decision tree? I used decision tree and guess what? It predicted a price of $32,000. Is it better than the previous algorithm? The previous one gave 27.86 or something. It's definitely better, right? It's definitely better. Now, no more surprises. By now, all of you understand that it's almost 80% of the code is almost the same. Let me show you one more model, KNN. K nearest neighbors. This is one more algorithm that you can use to solve the problem. Okay. Again, if you see, these are the only 2 things that will differ. Rest other steps. Do you see any difference in the other steps, friends? Do you see any kind of differences in the other steps? So do you understand that machine learning is technically a set of steps? That's it. You just need to focus and understand these bits to become good at it. That's all you got to do. Okay. So most of the code, if you see, is again the same, where again you're training 80% of the data, your question and answers to find the patterns. 20% you are asking questions where the machine is answering and you're comparing with your answer key. Based on this, you are getting a score. Based on this, you're getting a score which tells if that machine algorithm is good or bad. And finally, friends, if you're happy with that machine learning algorithm, go ahead and predict. So let's see how good is KNN. So let's see how good is KNN. 27.1, it is even worse, right? It is 27.1, which is even worse. I wouldn't go for KNN. One final attempt, we tried random forest, okay? We tried random forest, and friends, again, almost entire code is same, except the first two lines. You see the first two lines? This time I'm using random forest regressor and its corresponding parameters. Based on this, the rest stuff remains the same. Had I accepted this model and put it into use, my price would have been 31.77. So which model, my friends, was the best for all of you? 31.77 was the last one. So which model was the best? Which student is the best? The second one, decision tree. Okay, so this is how you can run different algorithms. You can validate your business output and see which output is sufficing your business need. But in this entire journey, did you realize that I have used almost 80% of the code repetitive in nature? Would you understand this pattern, this idea that almost 80% of the code is repetitive? And if you understand the basic steps of machine learning, the rest also falls into place. So for the sake of a lot of people who are asking different questions like what is algorithm, how do I use it? So what I'll say is today's session is not about mastering algorithms or mastering machine learning in a 1 hour session. It's more about understanding how it works in real life. A lot of people are under the assumptions that these are very difficult things. The coding is very complex. Nothing like that. I just showed you a beautiful way to figure out which algorithm could have been the best problem solver for you for deciding the price of these houses. And likewise, you can use such ideas at your company also. Whatever work you're doing, you can always go back and use it in the same way. Okay. So the whole idea, yeah, obviously this time also you didn't know. So Paddy says, but in real life, you won't know the actual output. Yes, Paddy, you actually don't know what is the actual output because I have changed in this to 2.28. This actual data, if you see, it is 2.16, 2.18. I've changed it to 2.28. So even I don't know what is the actual price, but I said the price would be somewhere close to 36.2. I never said it will be equal to. But are you still scientifically closer to 36.2? If I had just shown you this data and I had asked you, so Paddy, can you tell me what is the price for this house? You know, you would have given me a random value. Okay, so if I had just shown that these are the attributes of the house, can you tell me what is the price of the house? You would have come up with a random value. But now, because of machine learning, my predictions, you see, it is very close to 36,000. Okay, some are 27, some are 29, some are 31, some are 33. They are pretty close to each other. Okay, so obviously, friends, please keep this in mind that this is a 1 hour session. You can't learn everything under the sun. But if you have understood the idea that yes, machine learning is not very difficult, a lot of the code is very standard in nature. And if you understand the basic ideas of which algorithm fits into what problems, do you think it is going to be a real big challenge for you to actually start solving real world problems? Okay, so with that, I will halt our discussion on machine learning for today. I'll take 1 or 2 questions, but I'll move into the more important part as to how do you transition into this space. Okay, let me just see what are the questions. So I'll just take 1 or 2 questions. And friends, I'll again repeat, please understand that there are almost 300 plus participants today. So we are not teaching one person in isolation. So please don't ask questions. I have a doubt in this, I have a doubt in that. We are all trying to understand it from a very generic perspective, that what is machine learning, how simple it is, how useful is Python in this. Okay, that's the whole idea. Okay. Isn't machine supposed to change the algorithm, see which one predicts better and give us that? So that is something called as Raga. If you understand AutoMill, that is something that is coming up recently, where in future you wouldn't even have to do these manual efforts of switching out to different algos and parameters and judging them. First of all, as of now, the machines are not that smart enough that they will know what exactly to do. So as humans, we are the data scientists who have to solve the business problems at step 1. Post that, people would suppose that once machines become a little more mature, then you can actually expect the machines to solve the problems. Okay, what if I give the same value for the attribute? Sajesh, you will not get the same answer. Okay, not necessarily that you have to get the same answer. So let's just change it to 2.18. So you see this 27 will not become 36. Okay, it's because the machine has tried to generalize the idea. The machine is not trying to learn or mug up the idea. It is trying to generalize the idea. It is not going to even try its bit to come up with the exact answer. It's going to be tried. It will try to be scientifically correct, but not 100% correct. Okay. As of now, for today, what I would recommend is understand RMSE stands for error. So lesser the error, better the model, and R square is basically a score. So score means more the score, better the model. So you can look at from the error perspective or the score perspective. If you have the error, it's like in an exam of 100 marks, I wrote 10 questions wrong, which is like I got a score of 90. So my error is 10 and my score is 90. That's the whole idea. Okay, so this is a good way to evaluate. So a student who has 10 errors versus a student who has 8 errors. Who's a better student? Obviously the second one. This guy has got a score of 90 and this guy has got a score of 92. So this is higher. So this is lower, error should be lower and score should be higher. That defines a good student. So this is the basic idea of machine learning. And as you saw, applying machine learning is not very difficult. If you understand that machine learning is here to solve a lot of business problems and you don't have to be the expert in writing all the code. There are experts who have written the most of the complex code. You are the one who has to use it to solve a business problem. So use machine learning to solve a business problem and that should take you places. That should help you actually get done with your machine learning challenges. So let me do one thing. Let me share you our presentation for Insaid.